Hello, everyone. We meet again, right? We're still continuing on our study of organic chemistry. And yeah, once again, if you haven't subscribed, please remember to subscribe. And just remember that you can even reach me on email, mlungisi.m.ngosi@gmail.com for any questions. Otherwise, just drop a comment if you have anything, any positive comment or anything that you want to clarify. Okay, so today I want us to continue with our study of organic chemistry. The last time we had dealt with hydrocarbons. Okay, so those organic compounds that consist of just hydrogen and carbons only. So if you remember, we talked about alkanes, alkenes, and alkynes. So today I want us to take something different. Okay, so I'm going to cover reactions on organic chemistry on a separate video. Okay, so just for today, I just want us to focus on naming, and I wanted to actually just finish off all the other compounds. Okay, right, so let's begin. Right, so if we have a compound, say for argument's sake, that looks like that, and I did say the last time that I am going to draw our compounds without the hydrogens. Okay, you're not allowed to do that, especially I mean when I draw the structural formulas. So we said if we've got something like this, we know this falls under alkane, all right, because it's got a single bond, we've got two carbons, and in this case, this would be ethane, right? But what happens if we add a halogen? Now, if you note in your periodic table, in group number 7 of your periodic table, right, you've got a group there, special group called halogens, right? So those consist of chlorine, fluorine. Okay, let me just take out a periodic table just to show you quickly, right? So those consist of chlorine, fluorine, your iodine, and so on. So what happens when you've got halogens? All right, so let's say for argument's sake you've got a chlorine atom there. Okay, so how do we name this guy? So first of all, I want you to note whenever we've got chlorine, okay, we're going to use the prefix, okay, that's chloro. Okay, when we've got bromine, okay, we're going to use the prefix bromo. Okay, and when we've got iodine, we use the prefix iodo. There's one that I've left out here, that's fluorine. Okay, so fluorine, we use the prefix fluoro. Okay, right, so now what am I going to call this guy? So first of all, would I need to number for this particular compound? No, because either way, if I put it either on this side or that side, it wouldn't really matter. Okay, right, so in this case, this would be chloroethane. Okay, so the name would be, sorry, that's chloroethane. And by the way, that's just one word. Okay, so this is chloroethane. Okay, so I'm just going to adjust this a little bit. Okay, so that's chloroethane, right? So in this case, you can see you've got a halogen there. So we started by naming the halogen, and that's chloroethane. Now, I want you to please note in this case what happens when we've got a compound that looks something like this. Let's put a bromine there, okay, and let's put let's say another bromine there, right? So how would I name something like that? Okay, so first of all, would I need to number? Okay, of course I would need to number in this case because they're sitting at different carbons, so I would need to locate the position of my bromide atoms, right? So in this case, I'm going to number. Where do we start numbering from? Okay, we're going to number from right to left because it's closest to our functional groups, isn't it? Right, so that's 1, 2, 3. Okay, so in this case, this is going to be, so when I name it, I'm going to say at carbon number 1, I've got a bromo. At carbon number 2, I've got another bromo. So you remember what we said when we've got two of the same thing, right? So this is going to be 1, 2. Remember, I'm seeing two numbers next to each other, and please don't forget that comma. So that's 1, 2 dibromo. Okay, and we've got single bonds only. So this becomes what? So we've got 3 carbons in our parent chain. So this becomes propane. Okay, right. So taking another one. Okay, so by the way, if you can, when I draw a compound and you want to see the solution, just start by pausing so that you can actually just try and do it on your own first. All right, so that you'll get the hang of these guys. Okay, the hang of this concept. Remember, organic chemistry, you can only master it by doing, just like any language, right? You can only master any language by actually continuing to speak it, isn't it? So in this case, if you just rely on listening to me, you might not fully be able to grasp the concept. But if you are going to not just listen, okay, so I wanted to put, okay, so let's put an iodine there. Sorry about that. Okay, so in this case, I've got both an iodine as well as a double bond, right? So what do I do? Okay, so first of all, I would need to number. So the question is, where would I start numbering from? Which one takes precedence in this case? So in this particular case, it means that the double bond would take preference, right, in terms of numbering. Right, if it was the halogen alone, okay, if it was only the halogen, so in this case we would have numbered from right to left, because obviously it's closest to that carbon there, right? But now we see that the double bond is actually closest to the left hand side. So let's first identify. Okay, so that's going to be 1, 2, 3, and 4. Okay, so what do I have now? I've got at carbon number 4, I've got an iodo, right? So that's going to be 4 iodo. Okay, and then 4 carbons, that's what? That's but. Okay, remember, between carbon number 1 and carbon number 2, we said we take the smaller number, so that's but1. It's a double bond and the suffix is in. So this is 4 iodo, but1 in. Okay, right, get it? Okay, let's try another one. So what happens if I were to have, right, so yeah, let's try and make it as complex as possible. Okay, so that you can grasp the concept. So I've got a bromo here. Let's say I've got a chloro. Now I am adding 2 halogens that are different from each other, right? Now, if you remember what we said is that if we've got 2 things that are different, what we'll do is we will place them in alphabetical order, right? So what we're going to do, we've got a double bond there. Okay, we've got a double bond there, and we've got halogens. So we're going to, obviously, we first identify there's our parent chain, our longest chain, right? So this would be, in this case, 1, 2, 3, 4, 5. So that's going to be pent, right? That's pent. So we see we've got a double bond there, so that takes precedence, right? That takes preference. So in this case, are we going to number from right to left? So that's 1, 2, 3, 4, 5. Okay, so what we do is we're going to say, okay, first we start with our halogens, right? But which one comes first? Okay, so remember, we don't take a preference, the number rather doesn't take preference, but it's rather the alphabet, okay, the letter of the alphabet. So which one starts first? Of course, B comes before C, isn't it? So we're going to say, okay, at carbon number 4, right, we've got a bromo. So this would be 4 bromo. Okay. And then at carbon number 2, we've got chloro. All right. And we've got 5 carbons. So this would be pent. Okay. Please don't forget, we still need to number for the double bond. So it's between carbon number 1 and carbon number 2. So this is pent 1. And this is a double bond. So this would be in. Okay. Right. I hope you get that. So this is 2-chloro pent 1 in. All right. So that is how we're going to actually name when we've got halogens, right? So you always place them in alphabetical order if you've got different types of halogens. You know, I saw something interesting the other day. It looked very small. So they had something like this. Okay, so how would I name something like this? Okay, right, I want you to please note. Okay, so you've got chlorines, you've got fluorines there, and you've got a double bond. So would we need to number? Absolutely, because we need to give the position of our double bond, of our halogens, right? So if you can, just please pause this video, all right, and then try to name it on your own, right? And then after you do that, you can unpause and just see my solution, right? Okay. If you are coming back, welcome. All right, so let's see, how are we going to name this? We're going to say, so at carbon number 1, at carbon number 2, we've got a chloro, right? Okay, C comes before F. So I'm going to say this is 1, 2 dichloro. Okay. And then I also have 1, 2 difluoro. Fluoro. Okay. The spelling of fluoro there sometimes escapes me a bit. Okay, so difluoro, and then what do you have? This is going to be, well, it's not really necessary to say eth1 in, all right, so I can just say ethene, right? Because obviously if it's ethene, the carbon can only be between number 1 and number 2. Okay, right, I hope that makes sense, right? So very interesting name there. 1, 2 dichloro, 1, 2 difluoro. Okay, and please note, every time between a number and a letter, you always put a hyphen. Okay, right, so that is how we name those there. Right, I want to actually just take another one. We're in, all right, I don't want to stay too long on the halogens, okay, or on the haloalkanes rather. So what happens when we've got both an alkyl group? Now remember, what is an alkyl group? It's a group wherein we've got an or what we call a side chain, a branch, right? So let's say we've got a branched atom like that. Okay, so that's CH3. Okay, and then we also have a halogen. Okay, let's put a halogen there. Right, so how are we going to name this? Okay, so once again, which one takes preference here? It's going to be our halogen, right? So we don't have a double bond, so it's our halogen that takes preference. Okay, so in this case, what are we going to do? Okay, can you see we're missing a bond there? Remember, we said all the bonds signify the presence of hydrogen. Okay, right, you're not allowed to do this, but obviously for the sake of saving time. Okay, so where do we number from? Left to right, right to left? Okay, of course we're going to number left to right, it's closest. Our carbon is going to be at carbon number, our fluorine rather, is going to be at carbon number 2, and when I number from this side, it's 3 on this side. So in this case, I'm going to say, okay, that's going to be 2. Let's number first. That's 1, 2, 3, and 4. Okay, now note, I want you to note you've got fluorine, okay, and you've got methane. Okay, so again, it's the letter of the alphabet that takes precedence. It doesn't mean that you start with only the halogens, right? So when you've got those two, again, you'll use that same principle of letters of the alphabet. So what am I going to say? So this is going to be F comes before the M, right? Okay, so that's 2, that's 2 fluoro. That's 2 fluoro. Okay, that's at carbon number 3. We've got, okay, a side chain with 1 carbon, so that's a methyl group. Okay, so that's 3 methyl. Okay, and then what is our longest chain? Right, our parent chain in this case, this is going to be a bute. Of course, it's single bond, so we don't need to put a number, or rather, we don't need to put a position, right? So in this case, it's going to be 2 fluoro, 3 methyl butane. Okay, right. I hope you get it, right? Okay, so let's see. You can quiz yourself and give me the answer in your comments, right? I want to give you something, and if you can, just give me the answer in your comments when you watch this video. Okay, right, so let's put a methyl group there. Let's put in, right, okay. I want to see if you are getting this. So in this case, if you've got the answer to this, please just put it on the comments so that I can see that you really understand what we are doing. Okay, right, please remember to do that. Right, so what I want us to do is I want us to look at the one that we the other homologous series, right? So we are done with what we call haloalkanes. By the way, they are called haloalkanes, or in some cases they call them alkyl halides, right? That the haloalkanes or alkyl halides. So those are hydrocarbons with halogens in them. So we call them alkyl halides. Right, now let's go for the next one. Now I want us to move quickly, right? Then we have what we call a group called alcohols, right? Alcohols. Now, what do alcohols look like? So first of all, alcohols have got a functional group, right? And the functional group of alcohols, right, is the hydroxide ion, okay? Right, so it's the hydroxide ion. All right, so what happens with alcohols? And by the way, sometimes you can, you can draw the functional group this way, or I've seen in some cases where they give the functional group in that way, showing the bond between the oxygen and the hydrogen, okay? But otherwise, it's neither here nor there. The examiner won't penalize you for using one or the other, right? So we've got a group called alcohols, and the peculiar thing about alcohols is that we've got an OH, and what we have, by the way, the name of the functional group is just simply called the hydroxyl, okay, hydroxyl group, okay, or you can say the hydroxyl ion, okay, right. So in this case, what we do when we name, we just simply use all at the end. So we use the suffix all, okay? Right, and depending on which textbook you use, sometimes they just use enol or all, but I will use the suffix ol, right? So let's take an example. So suppose we've got, here's an alcohol here, Okay, so what are we going to notice an alcohol with? Okay, obviously it's got that OH group there, so there it is there. And how do we name this? Okay, so first of all, do we need to number? Well, in this particular case, you wouldn't need to number. The reason for that is that this is going to be ethanol, right? But so whether you put it this side or that side, it's still going to be at carbon number 1, right? So we just simply call it ethanol. Okay, so this is ethanol, right? 2 carbons, that's eth, all right? Right, so we're going to use now the prefix ethane, all right, so, and the suffix ol, right? So that's going to be at carbon number 1 and carbon number 2. I mean, sorry, we've got 2 carbons rather, so it means that we've got ethanol. Okay, now look at this. But what if we've got something that looks like that? Okay, now we've got an OH sitting there. Now, you see, so the position of the hydroxyl ion or the hydroxyl group is sitting at a carbon that is in the middle, right? So it wouldn't matter. By the way, before we get to the numbering part, so I want you to see. So I need to now be specific on where my hydroxide group is, right? So I need to say specifically where is it located. So I would need to say, okay, so we need to number. So where do we start numbering from? Left to right or right to left? It really wouldn't matter this time because it's at this is the carbon in the middle, right? So that's 1, 2, and 3, and you'll notice whether we number it this way, 1, 2, and 3, so it still would be at carbon number 2, right? So what are we going to say? We're simply going to say, okay, this is that's 3 carbons, so this is going to be propane, right? Okay, note that's propane. It doesn't have an E at the end, right? Propane, and at carbon number 2, I've got an ol. Okay, so that's propane 2-ol. There's nothing wrong, by the way. I've seen this done as well. So that's 2-propanol. Okay, notice every time between a letter and a number, you always have a hyphen there. Okay, right. So that's going to be 2-propanol. So just remember that we use the suffix ol for alcohols, right? Okay, so let's take some more examples quickly, right? So suppose we've got, let's say, something, all right. Okay, so there it is there. Okay, and by the way, how would this look in structure, in molecular formula, right? Right, so this would be very important for us to notice what it looks like in molecular formula, right? So this would be CH3. This is condensed formula, so this is CH3. This would be CH2. Okay, this would be CH with an OH, right? And CH3. Okay, so this is how I would write that. Okay, this is condensed formula, but I want you to note when you write it in structural form, notice there are 2 ways of actually expressing that. So you can write it as C. Now look, how many carbons do we have? 1, 2, 3, 4. So this is C4, right? Hydrogens. That's 3 plus 2, that's 5, okay? Plus 1, that's 6, okay? Plus another 3, that's 9, okay? So that would be C4, C4H9OH, okay? Or you can write it as C4H10O, okay? Right, so those are the 2 ways that I can write that, I can express that as a hydrocarbon, right? I mean as in molecular form. Right, now I want you to please note, so how are we going to name that guy, right? Do we need to number? Yes, we absolutely do. Okay, so what would be the name of this guy, right? So this, we're going to say carbon number 1, 2, 3, and 4. So this is going to be at carbon number 2, right? We've got an OH, so this is going to be that's butane, right? Not butane, right? That's butane, right? And that's going to be at carbon number 2, we've got an ol there. Okay, right. So it does happen at times that you've got an alcohol that might have a side chain in it, okay, an alkyl group. Okay, so suppose you are given something like that. Okay, how are we going to name it? Right, we're going to start with the side chain first, isn't it? So we're going to say, well, where do we start numbering from? Now, please, I want you to always note, you always start on the side, rather, that is closest to your functional group. But in this case, what is our functional group? It's that hydroxyl ion, isn't it? So we're going to say, I'm going to start numbering on that side. So this now becomes 2-methyl. So at carbon number 2, I've got that methyl group there. And then now we get to the longest chain. So our longest chain in this case, we say this has got 3 carbons. That's going to be that's propane. Okay, I need to give the location or the position of my functional group. That's propane 1-ol. Okay, right, great stuff. Okay, I mean, the same would be applicable even if you had halogens and so on. You'd still apply the same thing. Just remember to give the position of that functional group there. Okay, right. So that is alcohols, the group called alcohols. Now you've got another group that almost looks similar, but you want to be really careful. Now we've got aldehydes. Okay, right, I think you are getting the gist of this, right? So aldehydes. So how do we deal with aldehydes? So first of all, aldehydes have got a C double bond O with an H, and this can only be at the terminal carbon. That means the carbon at the end, right? I'm going to show you why that is the case, because you need those 2 carbons bonded with the oxygen, and then, I mean, not 2 carbons, rather, that double bond with the oxygen, and then with that hydrogen there, right? So now what you actually need to do is to say, okay, when I look at this, all right, I know that's an aldehyde. Okay, by the way, that group there is called a formyl. Okay, it's called a formyl group. Okay, right, they call it a formyl group. Right, this is just to make a distinction between it and the carboxyl group, right? We'll come to that in just a little while. So now, how do I name aldehydes? So the aldehydes have got a suffix al. Remember, the alcohols had a suffix ol, ol, right? These ones have got a suffix al. All right, so taking an example, so if I have, let's say, something like this, double bond O, let's bring this down a little, right? So double bond O with an H. Okay, right, so how would I name this? Do I need to number? Well, fortunately with the aldehydes, you won't need to number unless you've got a substituent, okay, or that is an alkyl group, or you've got perhaps a halogen in that compound. All right, so we will not need to number. Why? Because in this case, it will always be at carbon number 1. So whether the functional group, remember I said to you, it can only be at the terminal carbon, right? So whether I put it this side or that side, so meaning it can only be at the carbon at the end, right? So in this case, this is going to be, we've got 3 carbons. So this is propanol. Okay, right, so I didn't need to give a position because you can only have that group there, C double bond O with an H, only at the terminal carbon, the carbon at the end, right? So this became propanol. Okay, maybe let's take an example. So what if I were to have a situation where there is a substituent? Let's say I've got something like this. I'm sure you are getting it by now. Okay, just for it to look different. Okay, let me put it on. Okay, let's say CH3 there. Okay, right, and by the way, please note the group there, this would be CH3 CH2. Okay, they write it as CHO. Okay, or sometimes they actually show that double bond with H there. Okay, and then in molecular form, this is in condensed formula, right? So in molecular form, you'd have see, you've got 3 carbons. Okay, you've got 6 hydrogens, so C3H6 with just an O. Okay, right, so notice the general formula of it. This would be CnH2nO. Okay, right, and you'll see why I'm giving that general formula, because it does form it becomes a functional isomer with another group that we're going to talk about in a few. All right, now let's talk about the naming of it. So how are we going to name this guy? We're going to say, right, so do we need to number this time? Okay, of course we do need to number. We've got that side chain or that substituent there. Okay, in this case that's an alkyl group. It's got 1 carbon. So where do I start numbering from? Right, please, I want you to note, in this case it will always be from the side that has the functional group. Okay, so this is going to be, right, a functional group, C double bond O with an H. All right, please always be able to tell the distinction between this one and the one we're going to talk about in just a few, right? So C double bond O with an H, so in this case that's definitely an aldehyde, suffix is al, right? So I'm going to say this is carbon, where that's 4 carbons, but now remember we start with the side chain. We're going to say carbon number 3, I've got methyl. Okay, and then 4 carbons, this is going to be butanol. All right, so did you need to put in the 1 al? You didn't, because it can only be at carbon number 1. Okay, right, I hope you get the gist of it. All right, let's move on to the next one. Right, I want to try and finish all of them. So now we've covered aldehydes, right? And then we've got another group which sort of almost looks similar, okay? But so that's C double bond O, that's the functional group of it, okay? So that's C double bond O with carbons on the side. Okay, so it will always be in a carbon that's somewhere in between. Okay, that's not the terminal carbon. Okay, so that's C double bond O. Now what do we call this group? We call them the ketones. Okay, we call them ketones, right? Ketones, by the way, we use the suffix "-one". All right, so we use the suffix "-one" when we name them. Okay, so now how do I oh, by the way, the name of the functional group, okay, of ketones is called the carbonyl ion. So we call this the carbonyl ion. So that C double bond O that is in between, we call that the carbonyl ion, right? So when they ask you for the name of the functional group, okay, you'll say it's the carbonyl group. Okay, so that's the carbonyl group. Right, now let's take a few of them. Okay, let's see, how do we name them? Okay, so if we've got, so that means that you can never have a ketone that has 2 carbons, right? It would only make sense. Their carbons can only start at 3. Why? Because the double bond O can only be in a carbon that is not a terminal carbon. And if we've got 2 carbons, it means both of them would actually be carbons at the end in a sense, right? Right, so let's look at this quickly. Okay, so now how do I name this? Now please, I want you to note, you will need to number for this guy. All right, so this is going to be carbon number 1, 2, it's closest to from the left, 3 and 4. Okay, and I've seen another practice. I don't know if that augurs well with you. So what they do is that they name from the left to the right, and they also name from the right to the left, something like this: 1, 2, 3 and 4. And they say to you, okay, take the smaller number of the ones that you have there. So you've got 2 addresses there, but you take the smaller one. Okay, I don't know if that works for you. Great. Okay, but I always look at the closest side from my functional group, right? So in this case, what am I going to say? I'm going to say carbon number 2, right? I've got that on there, so I start with my prefix. That's going to be butane. Okay, note there's not an E at the end, so that's butane 2-one. Can you see that? So that's butane 2-one. Nothing wrong with saying 2-butanone. Okay, you can name it that way as well. Okay, right, now let's take another one. Okay, would you want for me to add an alkyl group as well? Okay, let's do that. Let's say here's a double bond O there. Okay, right, notice so suppose I've got an alkyl group there. So how am I going to name this? I'm sure you've got it by now, right? You're thinking to yourself, ah man, I'm getting this language of organic chemistry. Right, look at it. So I'm going to say, start with the alkyl group. So this is, where am I going to start numbering from, by the way? Right to left or left to right? So if you take that system, we said we number from the side closest to a functional group. In this case, a functional group is the, as we said, the carbonyl ion, that's C double bond O. Okay, so we're going to say it's carbon number 1, 2, 3, 4 and 5. Now we start with the side chain, right, with the substituent. So that's going to be at carbon number 4, you've got a methyl, so that's 4-methyl, right? And then at carbon number 2 you've got that, so I'm going to say sorry, that's not but, rather it's 1, 2, 3, 4, 5, that's pent, so that's pentane. Okay, and at carbon number 2 I've got an one. All right, so that's 4-methyl pentane 2-one. Okay, so that is our ketones. Please remember we use the suffix -one. All right, now let's move on to the next one. Okay, right, and what we're going to do at the end is that I'm just going to give you a mix of them. All right, so what I want you to do is when I give you that, I want you to pause the video, try it on your own first, and then we're going to name them thereafter. Okay, right, so now we've got another group. We call it carboxylic acids. Okay, so that's carboxylic acids. Now, so let's just remind ourselves, which are the homologous series that we've gone through? We've gone through alkanes, alkenes and alkynes. Okay, and we've gone through haloalkanes, the ones with the halogens, the fluorine, the chloro, the bromo, and the iodo. Okay, we've gone through alcohols, we've gone through aldehydes, we've taken ketones, and now we're talking about carboxylic acids, right? Now, carboxylic acids, as the name suggests, they are acids, okay? So what happens is that we're going to identify them. Now, please, I want you to be very careful on this one, right? If you remember, the ketones, all right, had a C double bond O, okay, that was in between two carbons, right? But this one has a double bond O with an OH, okay? So we draw the functional group like this. The name of the functional group is called the carboxyl group, okay? All right, some people prefer to call it carboxyl, okay? Whichever one you prefer, it's really up to you how you pronounce it. Right, so that's the carboxyl group. So in this case, I want you to please note there, okay? The difference between carboxylic acids and aldehydes. If you remember, aldehydes had that C double bond O with an H. You remember that? Okay, so please be able to tell the difference between the two, right? So in this case, I'm simply saying, so these are carboxylic acids. The suffix that we're going to use for carboxylic acids is oic, and then you put acid. Okay, so it's oic and with the acid. Okay, so let's take an example there, right? So suppose I've got let's say, okay, let's take a simple one with an OH there. Okay, so those are hydrogens. Okay, so what do I have there? I've got 2 carbons, right? So 2 carbons in this case, I know that's going to be ethane. Okay, I've got a double bond O with an OH, so that's oic, so that's ethanoic acid. Okay, as simple as that, right? So by the way, I want you to also note that with carboxylic acid, you can only have that group at the terminal carbons, just like aldehydes, right? So you can only have that group sitting at the terminal carbon. So in most cases, you might not need to number unless you've got something else, you know, like a side chain, you know, a substituent, or even halogen groups, right? So let me just do this there. So yeah, I have to remove that one. Right, so we've got C double bond O with an OH. So we have H there. Okay, right, so how would I name that? Okay, so definitely that is an alcohol. It's got C double bond O with our OH, so we know that is going to have 4 carbons. So I'm going to have butanoic acid. We didn't need to number. Why? Once again, you can only have that group sitting at the carbon, the first carbon, right? Or rather the terminal carbon, and you'll always name that carbon as the first carbon, isn't it? Okay, so those are carboxylic acids, right? Just by the way, so with carboxylic acids, so we're going to have C, so if you give the molecular formula of this one, that's going to be C4, right? Hydrogens, that's 1, 2, 3, 4, 5, 6, 7, 8, right? So that's C4H8. Notice the difference now. You've got 2 hydrogens. Can you see that now? Right, so in the previous one, we only had 1 hydrogen. In fact, let me just show you quickly. All right, so in the previous one, you had only 1 hydrogen. So if you notice there, all right, so if we were to take the functional group, in fact, let's go for this one. If we're going to take the molecular formula, so this would be C4, right? Notice this, you've got 4 carbons, 1, 2, 3, 4, okay? I think I robbed this one of a hydrogen. Okay, so how many hydrogens? You'd have 1, 2, 3, 4, 5, 6, 7, 8. So C4H8O. Okay, so it means if I were to take the general formula of ketones, it would actually be CnH2nO. Now, I want you to please note, doesn't this look like the general formula that we gave for aldehydes? So I want you to note that ketones and aldehydes are actually functional isomers of each other. Let me just show you what I mean by that. Let's take a ketone that has 3 carbons. Okay, so let's take one which has 3 carbons. Let's say it's a ketone. So let's write it out in full. So that's definitely a ketone, isn't it? Right? Why? Because remember we said we can only have carbon and that is not the terminal carbon, right? And then let's also take an aldehyde. Okay, so we said aldehydes have got C double bond O with an H, right? The terminal carbon. Okay, so let's put in our hydrogens. Okay, so now I want you to please note, so what would this be? This would be propanone, right? Remember, that's the ketone. Would we need to number? Well, in this case, you wouldn't necessarily need to number because that ketone can only be at carbon number 2, isn't it? Right? If you wanted to, of course, you can. You can say this is 2-propanone. Nothing wrong with that. Okay, but what about this one? Of course, for this one, we wouldn't need to number. We would say this is going to be that's propanal, right? You remember that we said for aldehydes you wouldn't need to number because it's always at the terminal carbon unless you've got a substituent. Now, one thing that I wanted you to note quickly, right, is if I were to write down what would be the formula for this guy. So this would be C3, right? Notice how many hydrogens? H6 with an O. For this one, C3, right? Hydrogens. That would also be 6 with an O. So you see, we say they're isomers of each other because, right, they've got the same molecular formula, all right, but structurally they look different, okay? So we call them, actually, we say that the type of isomerism that they have there, okay, is functional. They are functional isomers of each other. They are functional isomers of each other. So that means they've got the same molecular formula, right? But they belong to 2 different homologous series, or in this case, they have different functional groups, okay? Yeah, if you remember, we said the functional group of aldehydes, right? That's a formal group, and then the functional group of ketones, that's the carbonyl group. Okay, right. Continuing, moving right along. Okay, so remember we spoke about carboxylic acids, right? We said in this case they've got 2 oxygens, right? And we can just simply name them this way. All right, so just in case, I just want to show you there. Okay, all right, let's take a carboxylic acid. Let's say we've got double bond O with an H. Okay, what if I added a fluoro there? Okay, all right, so how would I name this? So this would be an OH. Sorry about that. Okay, so that would be OH there. So how would I name this? Of course, now first of all identify my parent chain. Okay, right, and then I know that I need to locate the position of my fluorine. So where would I start numbering from? Of course, from the carbon that has my functional group, isn't it? So it's going to be at carbon number 3, I've got fluoro. Okay, and then carbon number 3, I've got a fluoro. Oh, by the way, I didn't need to. So this is then going to be propanoic acid. Okay, remember it can only be at carbon number 1, right? So that's 3-fluoropropanoic acid. Okay, right, just taking a last one. Okay, let's say, what if I've got, okay, sometimes they can express it even double bond O with an OH. Okay, right? So how would I name this? Oh, by the way, general formula for this guy would be CnH2nO2. Okay, that's the general formula of carboxylic acids. Right, now, how would I name? Oh, yeah, I wanted to add something else. Okay, I wanted to add a CH3 there. Okay, so let's put a CH3 there. Right, so how would I name this guy? Okay, so once again, carbon number 1, carbon number 2, and carbon number 3. So this would be 2-methyl. Okay, so that would be at carbon number 2, you have a methyl there, and then obviously you've got propanoic acid. I hope by now you are champions, okay, of identifying or of naming, okay, these organic compounds. Right, now, ladies and gents, we are now going to go to the finale, the last one. Okay, right, now the last one is a group called esters. Okay, now with esters, by the way, you just have sorry, that's esters, right? So what happens is that you have a reaction between an alcohol. I'll actually go through this more when I go through reactions of organic chemistry, right? So an alcohol plus a carboxylic acid. Okay? So what that does is it gives us an ester plus H2O. Now you've got an acid catalyst there. They normally use sulfuric acid as a catalyst there, obviously because it has very good properties as a dehydrating agent, right? So you get an ester. So this is a typical condensation type reaction, right? You form water in it. So I want us to just quickly look at an example. So what happens with an ester? Let's say we take an alcohol. Let's take a, okay, and we'll talk about the different types of alcohols that you have. You've got primary, you've got secondary, and you've got tertiary alcohols. But we'll mention that probably in a different lesson, right? Let's take an alcohol and let's take a carboxylic acid. So deliberately, I'm just going to put the double bond O with the OH on this side. Sorry for squeezing that in so terribly. Okay, let's put it like that. So now I want you to please note. So what happens in a reaction between an ester and a carboxylic acid? So the reason why I'm writing down this reaction is so that you can see how to express this. I've seen questions, okay, where they say to you, write down a balanced reaction in structural formula, right, of a reaction between a carboxylic acid and an alcohol, right? They would give you whatever carboxylic acid and an alcohol. Now, I want you to please note, so what am I going to do here? I know that water is to be formed, right? Now, it really doesn't matter which OH and H you are going to take, all right? Although it is alleged, by the way, that the OH normally comes from the acid, okay? It's contrary to popular belief, obviously, from acids and bases, that the alcohol gives away the H+. This time around, apparently it gives the OH, but it doesn't really matter where you take it from. So I want to show you there. So now Look at this. I've taken the H, and the O. So what is that? That's H2O. So that disappears, right? That forms the H2O there. And then everything else you take and join together. So let's do that. So what do I have as a result? Okay, so I had carbon, all right? So that was what I previously had there. So H. Okay, now remember it was bonded to that oxygen. You remember, right? Now this oxygen bonds now to that carbon there, that carbon, and that carbon has a double bond O. Can you see? We took out the H2O, right? And then that carbon now has got a double bond O, okay? So that's O, that's that oxygen there. That's bonded to that C double bond O. And then you've got your H, okay? Right, so that would be an ester, okay? Plus H2O. Now, ladies and gents, how do we name an ester? All right, how would we name an ester? First of all, how do we identify an ester? We will always identify an ester. First of all, it's the carbon that's bonded to an oxygen that's bonded to another carbon that has a double bond. So that is the functional group of esters. Funny enough, they also call this the carboxyl group, okay, right? But that's neither here nor there. So in this case, we'll always recognize esters with that oxygen that is in line with your carbon atoms. Can you see that? Nah? Right, now, ladies and gents, how then do we name an ester? Please, I want you to stay with me and listen carefully, right? So first of all, you start by identifying the carbon, or rather the oxygen, that is in line with your carbons, all right? So there is my oxygen in line with my carbons, okay? So there it is. It's actually giving me in a way a separation between two things, right? So a separation, there it is there. So it's one compound, on the other side it's another compound. Now remember, where do esters come from? Okay, they come from alcohols and carboxylic acids, right? So now what you'll do is you will identify the side that has a double bond O. So where's the double bond O? It's on this side, right? And I'm not saying by so saying that the double bond O will always be on the right, okay? I'll draw it differently so that we can do it together. Right, so in this case, what do we have? There's my O that's in line with my carbons, okay? There's a side with double bond O. So double bond O usually comes from the carboxylic acid, isn't it? Right? So it means this side comes from carboxylic acid, okay? So now you don't start naming from this side. You start naming from the other side, the alcohol side, okay? So alcohol side will always be named first. So the alcohol side is the side that doesn't have the double bond O. So how many carbons do I have there? That's 2. So this is going to be ethyl. Okay, so it becomes an alkyl group. Okay, so that's ethyl. All right, and then you come to the side that has the double bond O. Okay, so this is going to be propane. Okay, and we say the suffix of esters is the suffix OATE, OATE. Okay, so this is ethyl propanoate. Okay, right, we're gonna do that again. We're going to try it again for ourselves, right? So we had two things there. We had an alcohol, we had a carboxylic acid, right? Okay, right, let's take another one. Let's try and name a different ester. let's say for argument's sake, there, okay, we've got okay, all right, let's just name that there. Okay, so this would be our ester. First of all, our O in line with carbons, right? So there it is there. Okay, right? So it separates between two sides, right? Sorry, I forgot to put that oxygen there. Please remember, everything else stands for a carbon. Okay, so first of all, we said, what do we identify? Let's identify the side. So this side has a double bond O. It means it comes from which side? It comes from the acid, right? So this is the acid side, but we don't name the acid side first. We name the alcohol side first. So we know this alcohol side first, right? Okay, so in this case, we're going to say, how many carbons do we have on the alcohol side? We've got 4 carbons, so this becomes sorry, that's butyl. Okay, that's butyl, that's 4 carbons, and then there's my side that separates there, so that's butyl, and then we go to that side, that's that's butyl, and then that's 3 carbons on this side rather. Okay, so that's butyl, and that's propanoate. Okay, so that's butyl propanoate. Okay, so should they ever ask you, they give you an ester like this, and then they ask you which organic reactants, okay, were used to form this ester. So now you'll say, okay, so I've got an ester that is made of a side with 3 carbons, and I know that must have been the carboxylic acid. So which carboxylic acid is it? It's going to be propanoic acid. So it's propanoic acid that formed this. Okay, and what did it react with? It must have reacted with, right, I want you to note, butanol. But remember, with alcohols, I would need to show the position of my OH, right? So this would be butan 1-ol. Okay, so it must have been propanoic acid reacting with butane 1-ol, okay, a primary alcohol, because remember, it must have been that the OH must have been sitting at that first carbon, right? With this one, we didn't need to number, because remember, carboxylic acid can only be at the terminal carbon, right? Whereas with alcohols, it could have been at carbon number 1, 2, or any of those other carbons, right? So that's butane 1-ol. And of course, it gave us this ester, which is butyl propanoate. You start naming the alcohol side, butyl, okay, butyl, okay, and then propanoate, and obviously our suffix is OATE. Right, so ladies and gents, I hope that was fruitful. All right, so if you've got any questions, as I said to you, what I would like to do is I want to give you just a sheet quickly, right, so that you can try and name them. Okay, I'm going to give you about 6 compounds. You try and name them on your own. All right, and after you've finished naming them, you can continue with the video just to see my solutions. Okay, right. All right, so here are my compounds. I want you at this point to just pause the video. All right, try to do this on your own. All right, just name them one by one, and once you are done, you can unpause to then look at my solution. Can you do that for me? All right, and if you struggle with any of them, obviously you can just send a comment there, and then just ask me to explain how we got to that solution. All right, let's do that together. Okay, welcome back. All right, so let's try and name the first one. Okay, so first of all, let's identify to which homologous series does it belong. We've got a C double bond O with an OH, right? So definitely that belongs to the group carboxylic acids, right? Okay, remember that, carboxylic acids. So do we need to number for this guy? No, we don't need to number, because carboxylic acids will always be at the terminal carbon unless we've got something else, and in which case we don't have any other substituent or even a halogen for that matter, right? So what are we going to name this? This is going to be butanoic acid. Okay, right, remember that's a carboxylic acid, right? Okay, let's go for the next one. All right, if you've got that right, super. Okay, let's go for the next one. So we've got, first of all, here's our spine. Okay, so this is actually our parent chain, our longest chain, isn't it? So we're going to say, all right, this is carbon number, by the way, the longest chain, that's 1, 2, 3, 4, 5, or you can even say 1, 2, 3, 4, 5. It still becomes the longest in that sense, right? Remember, the straight chain, rather the longest chain doesn't have to be necessarily a straight chain. Okay, right, so we've got a double bond O there that is in between carbons. All right, so that tells us this is going to be a ketone, right? Remember, an aldehyde can only be at the terminal carbon, the carbons at the end, right? So we're going to say, okay, so our longest chain is this one here. Okay, and where do we start numbering from? In this case, closest to our functional group. Our functional group is closest from that side, so that's 1, 2, 3, 4, and 5. Okay, now have a look at this. So what's going to happen at carbon number 2? We've got that functional group there, but remember, because we've got a substituent there, we've got a side chain, we're going to start naming that first, right? So I'm going to say at carbon number 4, I've got a methyl. Okay, and then I've got 5 carbons, so that's going to be pent. All right, that's pent. And at carbon number 2, I've got pentane, rather, pentane 2-one. I'm trying to put that AN there. Okay, pentane 2-one. Okay, so that's going to be 4-methyl pentane 2-one. Okay, right, let's go for that third one there. Okay, so I've got 3 carbons, got a side chain there, and I've got an OH. So that tells us, you're quite right, that's an alcohol, right? So my parent chain, my longest chain, is this one. I'm going to say, well, where do I start numbering from? I definitely need to give a location so that I'll give a position for my OH. So left to right or right to left, it really wouldn't matter in this case. So I'm going to say 1, 2, 3. This is at carbon number 2. I've got a methyl, right? And then I've got, again, at carbon number 2, I've got an OH, or in this case, I can just simply say propane. Again, at carbon number 2, all. Nothing wrong if you wanted to say 2-methyl 2-propanol. Okay, nothing wrong with that at all. Or for this one, if you wanted to say this is 4-methyl, all right, 2-pentanone, that still works. Okay, right, now let's go to the next one. Let's go to the next one. Okay, so I've written this in condensed formula, right? So first of all, let's see what's happening. So you've got a carbon with 3 hydrogens, right? You've got another carbon with 2 hydrogens. You've got another carbon with 2 hydrogens. You've got another carbon with an oxygen and a hydrogen. So it means, and look at this, oxygen and a hydrogen. Now notice, you could only have a double bond and 1 hydrogen. That's why it only had 1 hydrogen there, because it accommodated that double bond O, right? So this is what this looks like. So to which homologous series does it belong? It's got a C double bond O with an H at the end. So definitely that would be, so that would be an aldehyde, right? So in this case, this would be, so we would say this is butanal. We didn't need to number because it can only be at the terminal carbon, all right? Okay, let's take the next one. So this one now becomes, okay, I'm sure you can already see, there's our O in line with the carbons, right? So it means we had something like this. Let's draw it out. C with 3 carbons. That's a double bond O. That's an O in line with our carbons. And another carbon with 3 hydrogens, right? So we said you first of all identify that O there. So definitely that's an ester, right? So we said we name the alcohol side first. The alcohol side is the side that doesn't have the double bond O. So how many carbons do I have? Of course, it's just 1. So this is going to be methyl. Okay, so that's methyl. That's 1 carbon there. Then we go to that side. That's 2 carbons. So this would be ethanoate. So that's methyl ethanoate. Okay, right? And then the very last one. Okay, oh, what a complex monstrosity. Right, so let's try and name this. So where are we going to start numbering from? So in this case, we want to number in such a way that we've got the least combination of numbers, right? So let's see, if we said 1, 2, 3, 4, 5, and 6, okay, as opposed to 1, 2, 3, 4, 5, and 6. Now let's see. I would have 2. Yeah, in fact, it makes sense to number from left to right. I'd have 2, 3, 3. 2, 3, 4, and 4. Whereas if I use these numbers at the top, I would have, it would start at carbon number 3, right? So definitely I get a smaller combination from left to right. So using that one there, I would have 3, 4, and 5. Okay, so I get a smaller combination of numbers when I number from left to right. Okay, so let's try. Okay, let's try. Let's see if you got that correctly. Right, so first of all, we said alphabetical order. So definitely I've got a bromo, I've got a fluoro, and I've got a methyl. Can you see that? So B definitely comes first, all right? So I'm going to say this is going to be at carbon number 4 and carbon number 3 and 4. 3 and 4. Sorry, I'm using the numbers at the bottom, right? So at carbon number 3 and at carbon number 4. So we're not using those numbers there. Okay, please, I don't want them to confuse us. Right, carbon number 3 and carbon number 4. All right, so 3, 4, I've got 2 of the same thing. So the prefix there would be dibromo. You're quite right. Okay, so dibromo. Please don't forget that, right? So that's dibromo. And then at carbon number 2, I've got a fluoro there. Remember, F comes before the M. So at carbon number 2, I've got a fluoro. Okay. And then I have got a methyl at carbon number 4 again. So that's 4 methyl. Okay, sorry, I won't be able to squeeze in the rest of it there, but remember it's just one name, right? so that's 4-methyl. And then the last thing is obviously my parent chain. Remember, it was this one with the 6 carbons. So this is going to be hexane. Okay. Yeah, let me just write it underneath there. That's hexane. So that's 3,4 dibromo. That's 2 fluoro. Okay. That's 4-methyl. That's at carbon number 4. And that's hexane. It's all single bonds. Okay. Right. So I hope you've got all of that correctly. And we'll see each other next time. And by the way, as I did say to you, organic chemistry, you just need to keep practicing the language. You just fall off the wagon a little bit and you forget the stuff so easily. Okay. But otherwise, ladies and gents, it's been good to be with you. Hope that you'll enjoy the rest of your day. And please don't forget to subscribe. And by the way, you can hit me up on my email. That's mlungisi.m.nkosi@gmail.com. Otherwise, from me for now, it's goodbye. Sharp, sharp.